I want to start the conversation here, which is, you talk about the idea of physical immortality, and you say that this is going to be possible by 2045. Explain yourself.
Well, I'll never be able to come on the stage and say I've done it. I've lived forever, because it's never forever. But I talk about 3 bridges to radical life extension. I've written a few health books. Bridge 1 is what you can do right now to stay healthy the old-fashioned way so that we can get to Bridge 2. A key idea of mine is that information technology progresses exponentially, and health and medicine is now an information technology, and that was enabled by the Genome Project, which was a perfect exponential. And that first genome cost $1 billion. We're now down to a few $1,000s per genome, but it's not just collecting this object code of life that's progressing exponentially. Our ability to understand it, to model it, to simulate it, and most importantly, to reprogram it is growing exponentially. And we're now getting clinical applications of biotechnology. For example, you can now fix a broken heart, not yet from romance. That'll take a few more developments in virtual reality, but we can actually, half of all heart attack survivors have a damaged heart. We can now fix that by reprogramming adult stem cells. We're regrowing organs, successfully installing them with the patient's own DNA in animals, and we'll do that in humans soon. We could talk all day about these examples. What's now a trickle will be a flood by the end, within 10 years. That's Bridge 2. And that'll get us to Bridge 3, where we'll have medical nanorobots, little robots that are computerized, that are the size of blood cells, that basically finish the job of the immune system. We have intelligent devices the size of blood cells that keep us healthy. They are blood cells, our T cells. But they evolved thousands of years ago, and it was not in the interest of the human species for us to live very long. So they don't recognize cancer, for example, because that gets us later on in life. It thinks, oh, that's me, and doesn't go after it. We can finish the job with these medical nanorobots. There are detailed designs, actually, how to go after every disease once we have these devices. That's a 2030 scenario. So that's the third bridge. Ultimately, we're going to merge with artificial intelligence. We can talk more about that.
The singularity. The reason I wanted to bring this up is just the idea as we all sit here trying to understand what the future actually looks like. And part of that future, in your mind at least, is something known as the singularity.
Right. Well, we start with the idea of extending our mental capacity with AI. So we've already done that. You misplaced your cell phone, so you're not enhanced at the moment. But most people, if they leave their cell phone, they feel like they're incomplete. So they're not yet inside our bodies and brains. There are some people that have computers in their brains, like Parkinson's patients, but that'll be routine in the 2030s. Another application of these medical nanorobots will be to connect our neocortex, that's the outer layer of the brain, that's where we do our thinking, to the cloud. Now, if you remember, 2 million years ago, we got these large foreheads. We were, before that, walking around with a slanted brow and no frontal cortex. And we got this additional quantity of neocortex. And what we did with it is we put it at the top of the neocortical hierarchy. And as you go up the hierarchy, issues become more interesting and more complex. And that was the enabling factor for humanoids to invent language and art and poetry and newspapers and conferences. No other species does that. But it was a one-shot deal. Our skull couldn't keep expanding, or childbirth would have been impossible. We'll connect our neocortex wirelessly to the cloud, just the way your cell phone does it. Most of the things you do with that do not take place in the phone. They connect to the cloud. The cloud is pure information technology. It is doubling in power every year as we speak. And we will then connect to simulated neocortex in the cloud and add again, just like we did 2 million years ago, to our neocortical hierarchy, but this time it won't be a one-shot deal. The cloud is pure information technology. It's expanding exponentially. And so we will be a hybrid of biological thinking and non-biological thinking, which I believe has already started with these devices outside our body. And we'll become smarter. By 2045, we'll expand our intelligence 1 billion-fold. That's such a profound transformation that we borrow this metaphor from physics and call it a singular change in human history.
When do we get to designer babies? And I asked because I had spent some time in a research lab in Berkeley working with CRISPR, gene editing tool, which is really on the cusp of where all of this may ultimately go. Do you think that's realistic?
Yes, I mean, certainly there are genetic diseases we would want to edit out that are just devastating diseases, and that we are beginning to now and making exponential progress in understanding the genetic codes that cause those diseases. That, you know, if you were told you could edit that out of your child's genome, you would want to do that. I think that's much less significant than augmenting our intelligence through artificial intelligence. That's going to make us vastly more intelligent, far beyond what we could sort of engineer by optimizing our biology.
Right. Okay, final question for me, and then I want to throw it open to the audience. This is news you can use. Ray happens to take 90 different pills a day because he plans to stay alive for a very long time. Walk us through your regimen.
Okay, well, people say you take all these supplements and other pills, that's going to enable you to live hundreds of years, and the answer is no. That's just to get to Bridge 2, and Bridge 2 is not far away. According to my models, 10 to 15 years from now, we'll be adding more than a year every year to your remaining life expectancy. Now, life expectancy is a statistical phenomena. You could have a computed life expectancy.
Hold on, how old are you now?
People think I look pretty good for 95. I'm 68.
Okay, so tell us what you take.
Well, that would take us all day, but I'll give you one example of an actual prescription pill, metformin. It's a diabetes drug. We've known for years that all the people that take metformin, and there are millions because it's the most popular diabetes drug, have much lower cancer rates. So I did some research with some MIT scientists, and we discovered why. It actually kills cancer stem cells, which are the real cause of cancer. Now, people don't take it optimally, and you really need to take 500 milligrams every 4 hours to maintain a level that will really keep...
Is that what you do?
Yeah.
Okay.
But even people who take, one every 24 hours have some protection, and we see dramatically lower cancer rates as a result. It's also a caloric restriction mimetic, meaning it causes some of the same changes that eating less causes without eating less. So I actually recommend anyone over 50 take that. So there's a long story.
We all want to call our doctor or go to Walgreens immediately. Tell us what else is on the list. Couple. And then I'll give it over, but this is selfish.
Phosphatidylcholine is you can buy it at Whole Foods. 90% of your cell membrane is that substance, that lipid. When you're 10, it's reduced by 90 or 95% by the time you're 90. That causes the organs to work less well. That's why your skin gets less supple. That's why the baby's skin is so soft and smooth. You can reverse that by simply supplementing with that substance. So there's a lot of different stories. I've written several health books about this.
Hi, Scott Lowen. The idea of radical life extension is exciting, but on a planet where the population is growing increasingly exponentially, talk a little bit about sort of resource utilization and sustainability, and how are we going to solve those issues?
Right. Well, as you know, the first thing that happens when nations get wealthier is the population growth rate goes negative. When we start to significantly reduce the death rate, the population will go up again. We have far more resources than we need. Take energy. So Tom Friedman, I don't know if he's here, but he's written a lot about energy. We have exponential growth, for example, in solar energy. Larry Page and I, this is before he became CEO of Google, were asked by the National Academy of Engineering to study emerging energy technologies. We selected solar because it had been growing exponentially for 25 years, doubling every 2 years. At that point, it was 0.5% of the world's energy, and people said, 0.5%, it's a nice thing to do, but it's a fringe player, ignoring the exponential growth, because that's only 8 doublings from 100%. Now it's 2%, still growing, doubling every 2 years. I think Tom has a graph in his book that shows that progression. That's only 6 doublings from 100%. So I presented this to the Prime Minister of Israel recently, and he said, he was actually in my class in the Sloan School in the 1970s, and he said, Ray, do we have enough sunlight to do this with? And I said, yes, we have 10,000 times more than we need. Once we meet all of our energy needs from solar, we'll be using 1 part in 10,000 of the sunlight. And that's just an existence proof, because there's a similar story with geothermal, tidal energy, and wind, and so on. We have thousands of times more energy than we need. I mentioned vertical agriculture. That will provide food at very low cost for the entire population. We'll be able to print out the other physical things we need ultimately with advanced AI-controlled manufacturing technologies in the 2020s. So we'll be able to meet the material needs of the population. I talked about snapping together homes from 3D printed Lego modules. But land, I mean, we're all crowded together. Well, we're crowded together because we created cities as an early technology so that we could work and play together. Now that virtual reality, it's not yet competitive with real reality, but it's becoming more so. We are spreading out. My work group is all over the world, and we communicate just fine. That'll become more realistic as virtual reality and augmented reality become more realistic. Try taking a train trip anywhere in the world, and you see that 98% of the land is not being used. We use 40% of it for horizontal agriculture, which we'll replace with vertical agriculture. So we have plenty of resources for an expanding population. Even when we dramatically cut the death rate, the biological population will only double every 15 years or so. The power of these technologies doubles every 1 year. That's the exponential growth that I call the law of accelerating returns.